The last technique that we are going to talk about is proof by the principle of inversion. So suppose that we have this inference rule. The conclusion is J, and we have premises J1 through Jn. The conventional way of interpreting this rule is we read this rule in the top-down direction. That is, if we have proofs of these premises, then we apply this inference rule, and then we build a derivation tree for the conclusion judgment J. Now, suppose that this is the only inference rule that deduces J. So in other words, there is no other inference rule that deduces judgment J. This is the only inference rule that deduces judgment J, so we don't have any other inference rule of this form. If this is the case, then we can employ this technique of the principle of inversion, which means that if you have a proof of this judgment J, then you may assume proofs of these premises. So now we are reading this inference rule in the bottom-up way. The conventional way of reading this rule is top-down. That is, we build the proofs of this judgment in the premises and then move downward. But if this is the only inference rule that deduces J, then what that means is that if we have a proof of J, then we may assume proofs of J1 through Jn. This is because the existence of the proof of J allowed us to assume this derivation tree because this is the only inference rule. This is the only inference rule. So the last inference rule in this derivation tree must be this inference rule because we assumed that this is the only inference rule that deduces J. So now we have premises J1 through Jn. So we must have a smaller derivation trees proving J1 through Jn. So therefore, we may assume all these premises J1 through Jn are provable because we must have their derivation trees. So that's what is allowed by the principle of inversion. So here's an example. Let's recall the inference rules for this judgment for natural numbers. So these two guys are the two judgments for natural numbers. And if we analyze these two inference rules, we notice that this is the only inference rule that deduces a judgment of this form: successor net, a success n net. So whenever you have a proof of this judgment, you may assume that the last inference rule in the derivation tree is this inference rule. So now let's invert this inference rule. If successor n net is provable, then the last inference rule in this judgment, so the last inference rule in the proof of this derivation in the judgment in this derivation tree, it must be this inference rule because there's no other way to prove this judgment. Therefore, there must be a derivation tree, a smaller derivation tree proving n net. So therefore, we have a proof of n net. We may assume that n net is provable. So essentially, we are inverting this inference rule in order to read the rule in the bottom-up direction. We start with the conclusion and then assume a proof of the premise. So in this way, we invert this inference rule. Thanks to the fact that this is the only inference rule that deduces a judgment of this form.